Assalamu alaikum wa rahmatullah. Hello everyone. In this video I will be starting with question 2 from the coverage of a grade 12 elite for term 3. So this file has 3 suggested questions from the college board. So this is the first one. It says a particle moves along the x-axis in such a way that its acceleration at time t for t is bigger than or equal to 0 is given by a of t equals 4 cos of 2t. This is the acceleration. At time t equals 0, the velocity of the particle as v of 0 is equal to 1. This is an initial condition. And its position is x of 0 equals 0. Part A, write an equation for the velocity of the particle. We are given the acceleration. We have to find what? We have to find the velocity. So to find the velocity of the particle, you must integrate the acceleration function, dt, right? So v of t will equal to the integral of 4 cos of 2t dt, right? So what is the integral of cos of 2t? First of all, the 4 is constant, it's a coefficient, we can leave it in front. So this is 4. Now the integral of cos is sine. So this is sine of 2t divided by t. It's the opposite of the chain rule. In the chain rule, we used to multiply by the derivative of the inner. Now here the inner is linear, we can differentiate, we can divide by its derivative. So you can divide by 2 plus c. This is v of t, right? So we can use the initial condition now. We can use the initial condition v of 0 equals 1 to find the value of c, okay? So replace t with 0 and v of 0 with 1. So this is going to be 1 equals 4 over 2. We can just write it as 2, right? We can write it as 2 sine of 2 times 0 plus c. Well, sine of 0 is 0. That means c equals 1. So the final answer for v of t at any time bigger than or equal to 0, it will be 2 sine of 2t plus 1. This is the velocity function. This is v of t, or the equation of the velocity. So this is part A. Let's do part B here. Part B says write an equation for the position x of t of the particle. Well, the position x of t is given by the integral of v of t dt. So x of t is given by the integral of the amount we got in the previous part, which is 2 sine of 2t plus 1 dt. Now we can integrate, okay? So x of t is equal to 2 is a coefficient, leave it. The integral of sine is negative cos of 2t, but you will divide by the coefficient of the 2t, which is 2, plus the integral of 1 is t plus, well, here you can write c, but I'm going to write k, okay, because I have used c in part A, so I don't want to mess the c's up, so I am using k. It's just a constant, okay? So we can use the initial condition. Now we can use what? 0 and 0 to find the value of the constant k. Still, again, you can name it c, okay? So x of 0 will be 0 is equal to negative 2, well, 2 we can cancel them. So minus cos of 2 times 0 plus 0 plus k, and in this case k would be minus 1. Get it to the other side, it will be 1. So we've got k equals 1. Now x of t would equal to minus cos of 2t plus t plus 1. This is the position of the particle. Well, part C says, for what value of t between 0 and pi is the particle at rest? So what does at rest mean? We all know that at rest means v equals 0. So you just need to set v of t equals to 0. So let's do it down here. So this is part C. Setting v of t equals 0, you get 1 point, okay? So you must set the velocity, which is 2 sine of 2t plus 1 equals to 0. You get 1 point for this, okay? Now, move the 1 to the other side, so you have 2 sine of 2t equals minus 1. Divide by 2, divide by 2. So, sine of 2t equals negative half. And then solve this. You can get for t 7 pi over 12 and 11 pi over 12. So let me give you another or a simple technique using the graphing calculator in which you can get those two values. You know, most of you already knows what I'm going to explain. So 7 pi over 12 and 11 pi over 12, how did we find them? You can directly say what? Your calculator, your graphing calculator, there is solve n, right? You open a bracket. Now you write the velocity equation, which is 2 sine of 2t plus 1, set it equal to 0. Now comma, this is the setup in your graphing calculator. Well, in our calculator we don't have t, but we have what? We have x, so make sure you use x here, okay? And our variable is x, and our variable goes from 0 to pi, and then close your parentheses here. Shift solve or whatever in your graphic calculator, you get x equals 7 pi over 12, comma 11 pi over 12. Those are the t values, but the calculator gives x value, so it's the same. This is the first question. Good luck.